So what we have here is, so far, just to recap, 56, we're going to find 75% of it. So we can multiply it together and get 42. Or we can do a percent table, where we break down our 100% in this part right here, and build it back up to 75. We break down the 56 and build it back up to the whatever we did with the percents. So 100% divided by 4 is 25%, times it by 3 gets 75%. 56 divided by 4 is 14. 14 times 3 is 42. So I have 10 times 3 is 30, and 4 times 3 is 12, so that gives me my 42. Okay, is everybody doing good so far? Now, in the next part, we have the next is we're going to do 5/6 of it. Okay. So once we get our 42 here, we're going to do 5/6 of that. Okay, how are we going to do 5/6 of 42? Any ideas?
In my mind, from what I've learned in school, I times the 42 by 5/6, and then 42 will go into the 6 7 times, which then makes it 7 times 5.
Okay.
You reduce it. I don't remember the principle, but
yeah, we'll be getting to those kinds of things. But yeah, of means times, so you can multiply them together. And did you say you wanted to simplify before you multiply?
Yes.
The diagonals here?
Uh-huh.
Okay, this 6 goes to 1, and that one goes to 7. And we get 35. Okay, good. So there's one way of doing it. Another way is that you can take 1/6 of 42, similar, and then multiply by 5. 1/6 of 42 is 7, and times 5 is equal to 35. Because what you're doing is you're breaking up the 5/6 into 5 times 1/6, and then the of 42 comes down to be times 42. And when you're breaking it up like that, we can use the associative property to say 5 times 1/6 times 42. And that's 5 times 7. Okay, so that's why that thinking works. Okay. Good. Next one is times that by 3. So we need to do 35 times 3. Okay. 35 times 3. Anybody know how to do that mentally in their head?
Well, 3 times 5 is 15, and 3 times 30 is 90, so it's 105.
3 times 5 is 15. Gosh, what's he doing that for? Stay there. Okay. And then you said 30 times 5 is 1.
30 times 3 is 90.
Well, 30 times 3. Okay. My iPad's giving me troubles. Stop it, iPad. I don't know why it's not doing this. It's not a good sign. Oh. $30 times 3 is equal to 90. And so 90 and 15, is that what you did? Let me.
Yes.
Going to say 5 times 3. 5 times 3. Now, when you do that, yeah, 105. Does that look good? So you can do that because of the, 105. Let's try a new one. So we're doing 35 times 3. And that's the same as breaking up. What's that?
It's not writing.
No, it's not. What is going on? Okay, let me reshare it. Don't act up today. Okay. Thanks for your guys' patience. All right, so we're breaking up the 35 into 30 plus 5 times 3. Okay. And you're going to distribute the 3 to the 30 and the 5. That's where the 30 times 3 comes from, plus the 5 times 3. Okay, there we got that. Okay, so we're just learning some mental math tricks. We're going to add 3. Okay, and that will give us 108. We're going to take 2/9 of that. Right, 2/9 of that is, let's see, how are we going to do that? 2/9 of 108. Any ideas for that one?
Divide 9 by 108 and then times it by 2.
Good. Okay. So 108 divided by 9. This is what we call in 2015, we call it an equation stack. So I'm just showing the steps that you just said. So that's actually 12. And I take my 12 and I multiply by 2. 24. The other way to do it is called an equation string, where you take 2/9 times 108, and you do what we did before. You just write a series of equations where we split up the 2/9 into 2 times 1/9. So 2/9 becomes 2 times 1/9 times 108. And that's equal to 2 times 1/9 times 108 by the associative property. We did that already just a little bit ago. 2 times 12, and that's 24. Okay, so you can track each operation in blue, and I've tracked it as an equation in red. Okay, so that they're all legitimate mathematical moves. Okay. After we take 2/9 of it, we're going to times it by 100. Just put 2 zeros after it. Take 25% of that. This is looking familiar. Did we do this one already? This is looking familiar. That's okay. No. Okay. Don't know what's going up with my iPad. So 25% of 2400, we can do our percent table again. It's where we start with 100%, and we can relate that to 2400. And then we get divide by 4 to get to 25%. And 2400 divided by 4 is 600. Okay. We're taking 3/4 of 600. Which we can still do. We can take 600 divided by 4 and then multiply by 3. 4, 600 divided by 4 is, when 4 goes into 6, you can do 60, that's 15. 150 times 3, 450. 10% of this, that just gives me 45. Just move the decimal over. And then put it in there, and we got the right answer. Check, it says on my phone. Okay, so that's 30-second challenge for today. Sure looked awful familiar though. Does anybody have any questions on homework or anything like that? Okay, so if you do later on, you can go ahead and send me an email or something we can meet. I'm gonna go ahead and take attendance. All right, thank you for waiting for that. Soon I'll put those up on the grade book so you can know what percent you're attending, but it won't like be factored into your grade, but you just need to have 90% attendance for the course. Okay, what we're gonna do is we're gonna go ahead and continue on with our unit number 2, which we'll start talking about fractions. Share screen. Okay. Unit 2, section 2 today. And we're going to do some more exploring with fractions. What we started last time was little models, shapes to show equivalent fractions as a picture, okay? So we studied these concepts at different levels of abstraction. We can do concrete models, we can do pictures, and we can do abstract models. So we're going to do some drawings of equivalent fractions, and we're going to do it with bar models. Okay. So for our first example, equivalent fractions with bar models is what we're talking about. Now, what you will want to know how to do is that you'll want to know, our first example is 1/3. We need to be able to write 2 equivalent fractions to 1/3 and be able to draw them with bar models. So here's like a bar model for 1/3. I'm going to draw it longer because the pieces will get small. Okay, so here's 1/3. What other, we need two other equivalent fractions. Can anybody name two equivalent fractions for 1/3?
2/6.
Okay. I'm gonna put equals vertically and do 2/6 equals vertically and 3/9. Okay. And we want to draw bar models of them so that we can see what equivalent fractions are like. Okay, go ahead and draw that yourself. I'm going to take a pause for just a second. Oops. Screen share. Okay, 1 second. Okay, so we are doing bar models for equivalent fractions. When you do equivalent fractions, you want to draw the bar models the same length. Okay, and they're equivalent. So here's I draw 1/3 for each of them. So when you draw fractions and depict them, you want to draw the denominator first. Take your whole, draw your denominator first. Now, with 1/3 is, I'm going to go ahead and highlight that blue because you want to indicate how much of the whole and the partitioned whole that you're talking about for your numerator. And for equivalent fractions, they have the same amount, same value. So for my distance here in my bar, these next two fractions are going to cover the same amount. Okay. Now, when I notice that the denominators are different, 3, 6, and 9. Okay. So the denominator has changed from 3 to 6 from my first one to my second one, which means that instead of having 3 pieces, I have 6. But 3 and 6 are related such that 6 is the double of 3. So I'm going to double the amount of pieces in my partitions, okay? Is everybody following that okay? I'm doubling the amount of in the picture. So every partition has twice amount of parts than it did with the 1/3. Twice the amount. So I'm going to take this and I'm going to indicate this with dashed lines. So so every part from 6 and 3rds, when you compare them, they have twice as many. So I'm going to take each one and divide into 2 parts. And I usually indicate this with dashed or dotted lines. So you can kind of see the relationship. When you go from 3rds to 6, you have twice as many. Twice as many pieces in each partition. And it's kind of small, but I'll give you an idea. Now, once my denominator was changed from 1 piece in each partition to 2, my numerator automatically followed. And that's why you have to, when you do this abstractly with just numbers, you have to do the same operation and same amount as you do the numerator and denominator. So my one that I wanted became 2. So the highlighted one became 2. And so with this equivalent fraction for 3/9, I'm going to divide my partition my denominator into 9 pieces. I'm going to do it systematically so that each partition of 1/3 has been divided into 3 parts. Okay? And I go ahead and just shade the part that was in the numerator. So numerically, we have the 3 became a 9 because I took each of those thirds and made 3 more into each one of the thirds and partitioned them into thirds. So when you do that with each of those 3 thirds, you get 9 ninths now. And because of that, I partitioned my one, the one that I was highlighting, or the one that I want, has now been partitioned into 3 parts. Okay, everybody following okay? Okay, try number 2. 3/4. We need 2 fractions that are equal to 3/4. We need to draw them. Good. Let's have 2 fractions that are equal to 3/4. Anybody?
6/8.
Okay, 6/8. And one more.
9/12.
Yeah, good. I like how you guys are keeping it simple. Using smaller numbers so you don't have to do as much work. But completing the problem. So 3/4. You're going to divide these into fourths. Now when you divide bars or circles into fourths, it's pretty easy because you have to just draw a line in the middle, that to make it half, and then draw and split each of those halves into half. Okay, so that way you can kind of make it look nice, because when you present it as a teacher, you want to do a good presentation. So I'm dividing each of these into fourths by dividing my halves into halves. Okay. And I need to indicate 3/4. Okay. On all of them. But the difference is when you subdivide it, these pieces will become different numbers in the fraction because I'm dividing them into different parts. Okay, so I have the same amount highlighted in each of those 3 bars. And now I just have to subdivide them, like they're divided once, but now I need to divide them again. So that's what we call subdivide our pieces into the right amount. So from 3/4 to 6/8, each of my pieces was split into 2 parts. Okay, so I'm going to split each of my pieces into 2 parts here, all throughout. And notice that the numerator followed the denominator. 9/12 from 3/4, each of the pieces were split into 3 parts. Systematically, you get 9/12. Let's hope it behaves here. Great. Now, example number 3, what you can do is instead of splitting pieces into parts systematically, you can also combine them. This is what simplifying fractions does. Finding equivalent fractions that have smaller numbers, but the value is still the same. So you systematically combine the pieces together. Now we're going to start with 6/9, and we'll systematically combine the pieces to simplify the fraction. So this is what we did a little bit before. Okay, so 2 equivalent fractions where we're going to simplify. Okay, we're going to take a look at 6/9. Yeah, well, this is, yeah, anyway. Yeah, in this presentation, I'm going to skip the middle one. Because 6/9 doesn't combine nicely to 4/3, but 6/9 does combine nicely to 2/3, and this is the point of my exercise. Showing systematic combining of pieces. So when I want to do ninths, I can take my thirds, so I divide into thirds here, and take each one of those pieces and subdivide those into thirds, and you get ninths. If you want to draw ninths pretty nicely, you can take your thirds of thirds. All right, so there's my 6/9. I need to show 2/3 with them. Oh, whoops, that's just my ninths. Let me draw my sixth part here. 2, 3, 4, 5, 6. Okay. So I have 6 pieces shaded, each of which is 1/9. So if you remember what the definition of what 6/9 means, it's good to know this so that we can talk about it better when we do operations on fractions. 6/9 means 6 pieces, each of which is 1/9 of a whole. We're going to combine them together into 2/3. Now, we have to systematically combine them together. So 6 can be grouped into groups of 2 and groups of 3. Okay? But if we did groups of 3 here, we will not have systematic grouping, because if I did groups of 3 to make this, no, actually that was the answer. My point is that you can't just pick any group size. Let's say groups of 4. If I pick a group of 4 here and combine them together, then I won't have another group of 4 to combine. So it's not systematic grouping. I'm like, what do I do? You have to combine them so that they are nice and systematic, where you put them into equal size groups, because that's what fractions are about, all about equal sizes. So I'm going to combine them together into groups of 3. When you do that, you have the 2 groups of 3, which we'll divide right here, and divide right here. And combining them systematically. And then for the numerator, I've combined all those, but then here's the denominator that also needs to be combined, so that you have thirds. So you're taking 3 pieces and making them 1. Okay? So that's why you're going to divide here. Starting with the denominator, divide by 3. And then I take my 6, and it becomes 2 because I also divided by 3 here. And then we can redo our shading to show that. So the parts that I was looking for, that I wanted, or the numerator, and the first fraction is 6 pieces. The second one, all those 2 sets of 3 became 2 pieces now. Any questions so far?
I just have a quick one. Is the 2 lines between, is that like, you said, I think you said horizontal, is that the same as like an equal sign?
Yeah, I did horizontal equals. Going down.
Oh, okay.
Or right. Sometimes you'll see that in there, but not very often.
Okay, and then I know how to simplify fractions, but I'm like a little confused on how we went from 3/4 to 6/8 and then to 12. Are we just timesing those like by 2 every time, or?
So when do you like see numerically? It's a great question. So for this one, when you times it by 2 numerically, we consider the denominator first, even though the numerator is different first. Consider the denominator. I have 4 pieces here. 1, 2, 3, 4, and you make 4. Now, I want to write an equivalent fraction, which means I want the same amount.
You sound a little muffled. It's kind of hard to hear. Sorry.
Okay, so when you have 3/4, you're taking each of the 4s and you're going to split them up the same way. Write an equivalent fraction. I want the same amount, but I want different numbers, because you need to have equivalent fractions in order to operate on them.
Dr. B, you're breaking up.
Okay, so I switch. Okay, can you hear me better now?
Yes, a bit.
Yeah.
Okay, so it sounds like it's my end. Okay, so I have 3/4, and I need to write the amount of 3/4 in a different way by breaking up the pieces
Is everybody else muted? Like I don't know. It's just like a weird connection.
It looks like it is. Yeah. I looked on all the participants and it looks like it is.
Okay, go ahead. Sorry about that, Dr. B.
Yeah, on my end, I'm not getting anything that you just said, Dr. B. Can anybody else hear Dr. B?
No.
There we go. So we're ordering the fractions from least to greatest. That's good, you guys can tell. We're going to use the pictures here. So the fractions are 2/2, 1/6, 4/3, and 2/5. And so this is a concrete way or a pictorial way to order fractions. We want to depict each of the fractions using bars. The Menzies fraction bars are good for the concrete way. It's not that one. We want to do 1/6 next. You can compare them. And it's good to just practice drawing bars and partitioning bars into halves, thirds, fourths, fifths. And so 2/2. When you want to divide a bar in half, you want to just draw one line in the middle. And so when I'm talking about 2/2, I'm talking about both parts here, this one and this one. So 2/2 make a whole. 1/6. If I want to partition my bar into sixths, then I need to partition into thirds, and half, and then partition the half into thirds. So that's a good way to get to 6. Okay. And I'm just going to consider one of those. One piece where 6 copies make the whole. 4/3. Now if I want 4/3, I divide my bar into thirds, but I need more. So I need 4 of them. So I'm going to draw another whole. And divide that into thirds. And then I can highlight the 4/3 here. 1, 2, 3, 4. Remember, 4/3 means 4 parts, each of which are 1/3 of a whole. And then 2/5. Now fifths are not really easily divisible, so I just have to kind of like draw 4 lines in here. Okay. Something like that. Now 1, 2, 3, 4. If you draw 4 lines in, you have 5 spaces between them. We're going to go to 2/5. So we want to order them, which is we put the smallest one first and then the longest one after that. And so for time's sake, we just need to kind of go through this and tell you that 1/6, so you guys can see that. And we have, next one is 2/5. And then we have 2/2. And we have 4/3. Okay. Here's another example. We want to order them Order the following fractions from least to greatest. Using reasoning with numbers. So we're not going to do any pictures. We'll try it without pictures first. Let's see. 1/3, 1/7, 1/4. These are going to be unit fractions. And so I'm going to put that into my directions here. In 1/6. Okay, so we can use pictures or we can just reason about the numbers. We want to generate an idea here for unit fractions. So how do we know how big these are? Which one is the biggest one? Which one's the smallest one? Which one's going to be between? Go ahead.
So the way that I would picture it in my head is like that they're all like the same round like size pie. And then like if you cut a pie into 3 pieces, the one would be bigger. If it's in 7 pieces, the one piece is smaller.
Yeah, we can just kind of do that real quick. One that is divided into 3 pieces. One is divided into 7. That's really tricky. 1, 2, 4, 5, 6. Okay. One divided into 4ths. One divided into 6. So you can look at pie for sure. We're going to have blue pies. Okay. All right, let's see a pattern here. Which one's the biggest one? Which one's the smallest one? Which one's going between? Looking for patterns. We want to generalize about ordering fractions. What do you guys think?
The smaller the denominator, the bigger the picture.
Aha, great idea. And that's what I wanted to generate from this exploration here. I'm not sure if you guys realized that before, but it said the smaller the denominator, the bigger the piece. Okay? So your whole is divided into less pieces, so that means that they are big. Okay? Compared to other ones, if your whole is divided into lots of pieces, and that means each one is really small. So it works a little bit in reverse of what you might think from just regular numbers. So you can say the smaller the denominator, the bigger the piece, or the bigger the denominator, the smaller the piece. So you can say that too. So go ahead and order these fractions. Which one's first? Therefore, the order is smallest one's, the bigger the denominator, smaller piece. So it's 7th, 6th, 4th, and a 3rd. Okay, great. Here's another example. Order from least to greatest. Okay. 5/6, 6/7, 4/5, 7/8, 2/3. Okay. What do you guys think about that one?
It almost seems like it's kind of the same principle, but in reverse. So instead of just having one piece, you have all but one piece.
Right. of all but one piece. So 5/6, 6/7, 4/5, 7/8. And just draw some quick pictures. And 2/3.
So if you're doing least to greatest, it would go like the smallest first, right? The smallest denominator.
What do you guys think? What Camille said? Somebody else chime in?
I agree, because the smaller the number, the bigger the piece. So it's,
And so if you have all the pieces of it except one, then you're going to want to put this like the 8, 7, 6, 5, 3, because the one piece is going to be smaller, right? Or did I say it backwards? Or that was greatest to least, so it would go.
Yeah, least to greatest. So from here we can see that the least one is 2/3.
Yeah, so it would go like from the smallest to the biggest denominator versus the one on top, like the previous example.
Mm-hmm. So if you have a small number in the denominator, the pieces are larger. And that means that they are not as close to the whole as the larger denominators are. So they are further away from the whole. So that means they're the least one. So let me say that one again. The smaller the denominator, the larger the pieces are, which means if you have all of them filled but one, those smaller denominators are further away from the whole. And so I'm going to use this as my barrier here for the 2/3, for example. That's the piece. It's further away from the whole because the pieces are bigger. So 2/3 is the smallest one. And then we go from denominators to fifths. Then we went to 6/7, and 8. Okay. All right, so moving
Real
on.
quick, if there's questions like this in the homework, did you want us to show the bars of how we got the answer?
They'll show you in the homework. This one, I don't think has a homework question yet, but we will be doing things like this. So I'm starting it out here for you.
Okay.
So just the homework will say do this with the bar model or do this with the picture. Or just order it. If they don't tell you how to do a picture or anything, you can do a picture or you can just write the answer. Okay, so that's ordering fractions. Moving on, we need to do some bar models. We will be just setting up bar models in this homework, which means that we won't solve the problems or story problems that you use a bar to depict the people, the numbers, and the situation, so you know which operations to do. So we'll start that in this class, but we won't do it until 2015. You'll do lots of bar models. There's a whole unit on them, which are bar models are helpful to solve word problems or real-life situations. So in this example, John is baking a pie. So he baked a pie and ate half of it. Then he gave a fourth to his brother. So nice, right? What fraction of the pie does he have left? And so we have a bar here that we can depict it with. And there's some space for labels, so draw it down a little bit. Okay, so he eats half of the pie. So half, he ate. That's the half he ate. But then he gave away a fourth. And so this is where bars help you, like, okay, I need to redivide everything so I can know where a fourth is. And halves and fourths are related by the 2-to-1 relationship. So I take each piece and divide it into 2 parts. So you can use dashed lines to do that. And this is the fourth he gave away. Now the question is asking what fraction of pi does he have left? And when you can just do a question mark at the last part here. Okay. So you can do some coloring if you want. Half he ate, the fourth that he has left. And you can leave that one white. Right. So we're running out of time here, so that's an addition one. Addition of fractions, you can add them together like that. The next one is Sally. She's going to do something with her pie, she's going to do something. She bought pounds of apples. She bought 5/8 pound of apples. And then her friend bought 1/4 of a pound. We can do things like adding and subtracting them. So how many more pounds did Sally buy? Okay. Now you can depict this in a few ways, but in the book they were doing things like this. You have your bar. You have 5/8 to depict first. So you can divide it in half and divide those halves in half. I want 8s, I can take those fourths and divide each one of those in half. You get some 8s there. And we did 5 of those. 5/8 pound here. And we have a 4th that was bought, but we know that 2/8 is a 4th. So a 4th or 2/8 pound was also here. Now we want to know the difference, which is this part right here. That's where we put our question mark. So a 1/4 of a pound is bought on the bottom, and 5/8 total. You can do this kind of shading. Okay, just a few more minutes. What we need to do is we just need to show pictures of how to convert improper fractions or fractions greater than 1 to mixed numbers and vice versa. Okay, and then that's the lesson. So we're going to start with showing how to convert a fraction greater than 1. Sometimes you have people that say that improper fractions or fractions where the numerator is greater than the denominator are still fractions. And so improper is like not a very good word to use. Right? So when you're teaching, call it a fraction greater than 1. So I'm going to put that in quotes so you can remember that. Fraction greater than 1 to a mixed number. So our example for that is 10/7. So I want to show a picture of 10/7. Okay, so I just can count off 7s. 1, 2, 3, 4, 5, 6, 7. Okay, there's 7 of those right here. 8, 9, 10. And that's all I got. Here's the rest of it. So there's 10/7 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So I have 7/7 there, which is 1, and I have 3/7 left that are not part of my 1. So therefore, 10/7 is equal to 1 and 3/7. So you can show that with your picture here. There's my 7/7 there, and my 3/7 here. An example that you can work out on your own is 12/5. Let's see here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so here's 12/5. We got 1, 2, 3, 4, 5. I count out 5 and group them. 1, 2, 3, 4, 5. I count out another 5 and group those. And then there's 2 left. So that's 2/5. There's 5/5 here. That's 1. 5/5 here. That's 1. So 12/5 can be converted to 2 and 2/5. Okay, so you see the picture of the conversion. We can shade out the 2 here. Oops, a different color. Okay, so you can see the difference between the wholes and the part. Okay, one more thing is just a couple examples showing how to convert a mixed number to an improper fraction, or a fraction greater than 1. The mixed number that we had was 3 3/4. So you want to draw out the 3 3/4. So we'll draw 3 holes. And I need to draw out, well, those are too big then. Let's draw out you some more room here. Here's 3. And I need a 4th one because I have the 3/4 there. And if you guys need to go, that's okay. I'll post these notes and video and stuff. So I'm going to divide those into fourths. So there's 1 here, 1 here, 1 here, and then this needs to be the 3/4. So I divide these into fourths here. And one of these fourths has, one of these bars, holes, has 4/4 in there. The other one also has 4/4. No one has 4/4. We can shade them different colors. Now, I want to convert them into a fraction greater than 1, so I can take all those fourths together.
Why did you color in all of the 3/4 one?
See if you guys are paying attention. Because I don't need to do that, right? I only need to do just 3 of them. So yeah, that was a mistake, but you caught it. Good. Just stop there. Good. Now that's the number of fourths that we want. Okay, so we're going to count them all up. So we have 3 3/4 could be equal to 3 groups of 4/4 plus the 3/4, which is equal to 3 3/4. Okay. And the last example would be 2 2/3. So you want to draw 2 bars for my 2, and then a 3rd bar for my 2/3. Dividing them up into thirds, we have 2 here and 2/3 here. Okay. So I have 1 whole bar equals 3/3. 1 whole bar equals 3/3. 1 whole bar equals 3/3, but we don't have all of that one. We just have our 2/3 here. So 2 2/3 is equal to, you can also think about it like this, 3/3 plus 3/3 plus 3/3, no, plus 2/3. That will equal 3, 6, and 8. 2/3.
So on the
Yeah,
showing,
I missed this one up here. It's going too fast. Hold on. That's a mixed number to mixed number. 3 groups of 3/4 for this one should be 3 times 4 is 12. I'm going to do an arrow here. I'm going to add on the arrow here and add on the 3. So that makes 15. Okay, so sorry about that one. We need to keep them as fractions greater than 1. That's what we wanted. Okay, so that's hopefully a picture to show why you do the algorithm here, where you multiply the 4 times 3, and you add the 3 on there. So when you do the algorithm to get the mixed number to a fraction greater than 1, you need to know why it works. So 4 times 3 gives you 3 groups of the 4/4. And then you add on the 3/4, which is the partial group of 4/4. Okay. Taking 3 and multiplying it by 2 here, taking the denominator of the number of thirds, sets of 3/3, and you multiply by 2, you get 6/3. And you add on the 2/3 because there's 2 more that haven't been used yet. Okay, so right here we have 2 groups of 3/3. That's why we multiply. We'll talk about groups of objects with multiplication later. And then there's 2 more thirds here. Okay, that's why you add them on. Okay, so that's all I have for today. And hope you guys enjoy the homework. I'll go ahead and post the videos, the notes for you guys to use.
I think I wrote down the show how to convert a fraction greater than the whole, the first example we did in this one wrong. Can you just scroll up for 2 seconds?
Like that?
Yes.
Yeah, because I've had to go fast through these. So people
Yep,
can
no worries.
for next items for schedules. And I have a meeting at 3, but does anybody have any questions for the next 10 minutes?
Nope, I'm good. Thank you. Have a good day.
Yeah, you too, Camille.
Dr. B, I just want to confirm, so we have today's homework assignment and then Monday's homework assignment and the exam due.
Yeah, today's homework, there's a homework from yesterday or Wednesday that's due today. The homework from here is due on Monday. The exam is due on Tuesday, I think.
Okay.
Okay, let me know how things go. Send me an email if you're having troubles. Or if there are questions or if everything's going fine, then that'll be good too.
Okay, thank you.
Yeah, you're welcome.